Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what I'm going to go through is a very simple but actually a very powerful and straightforward network mechanism that has been proven for many years now to give specific network connections extra resiliency and extra throughput. What is that mechanism? That mechanism is called link aggregation group, or as it's commonly called, LAG for short. So in this video, what I'm going to go through is what is LAG? Why is it here? What are the benefits it actually brings? And I just mentioned two of them. And of course, how do you configure link aggregation group on Juniper Junos devices? Plus, what do you need to be aware of when you're configuring link aggregation group from a Juniper device to a non-Juniper device as well. So if you like this video, please give it a like. Please subscribe to keep up to date with the latest content which is coming out weekly. But other than that, let's just jump straight on the lab and let's get going. And so here's the lab that I'm going to be using for this video to give you the theory and the configuration details on link aggregation group. And I don't want you to think that, wow, that's quite a big lab. This is very scary. It's too much. I don't want to send you running for the hill. Don't worry about that. This is just my EVE-NG environment. But what you can see actually is that there's actually two switches, two Juniper VEX or Virtual EX switches just down here. And they both have got two links to and from each other. Good news there is those are the only two switches, the only two devices that we're actually going to concentrate on during this video. The reason why you're seeing everything is because you might be wondering when I zoom into it, well, what's ISP1, what's Enterprise B, what's this connection here, and what's that connection there? Don't worry about that. That is not the focus of this. This is for my BGP lab, but here the focus is on link aggregation group. Okay, and so I've just zoomed into those two switches. So here we've got R17 and R19. I'd made a mistake. These aren't actually VEX switches, they're VMX routers, but really, it does really matter for this purpose. But what I want to cover through first is when would you actually use link aggregation group? So first, let's just use this scenario here where say we don't have this connection here. So say this connection between R17 and R19 no longer exists, and we've only got this one connection here. That is a little bit of a problem, isn't it? Because we don't really have network redundancy. And I can speak from personal experience, professional experience, when I was a field engineer in London many years ago, where there's building work going on outside the building, and a contractor just outside of the telecommunications world was drilling through concrete in the streets and accidentally went through quite a few fibers. It does happen. And if you think about other cases where engineers accidentally disconnect fibers, maybe there's rats eating fibers in underground cables, the list absolutely goes on. Networks need redundancy. They need resiliency at the end of the day. And where we've got one service provider here and an enterprise here, really, would you be happy in your network, in your work? Maybe it's your own network. Would you be happy with it having one connection to the outside world? Maybe you would be, maybe you wouldn't be. Typically, when it comes to an enterprise service provider connection, they would have two connections going from that service provider or from the enterprise here over to that service provider. So if one link goes down, there is still that redundancy. That network is still connected to the internet, to all their cloud applications, and a lot more. But if we look at it from inside the enterprise perspective, why would you use link aggregation group in the enterprise? Well, it's still really the same concept, whether it be enterprise or data center or inside the service provider networks, is we want to keep as much uptime as possible if a link should be chewed through, drilled through, disconnected, whatever it may be, or maybe just the link on the interface itself goes physically down or administratively down. We need that uptime. So what the first benefit of link aggregation group, and I will define what link aggregation group is in just a second, but the first benefit of link aggregation is resiliency. As I've said there just a few times, when a link goes down, if there is a backup link or an extra link to that same destination from that same source, then the link aggregation group will basically share, it will load balance those frames, those packets over all those available links. A second benefit is cost. Unfortunately, we live in a world where money pretty much just drives everything. That's a separate topic, I know, but it's very costly to deploy fiber from an enterprise to a service provider inside the enterprise itself, inside the data center. It doesn't matter if it's actually fiber optics or Cat5, it doesn't matter. You've got to have an engineering team there to actually deploy that fiber, to deploy the cable, maybe do some kind of fiber inspection or optical time domain reflectometry, OTDR traces on that fiber. It's a very costly process. So if you can actually deploy 2 fibers, 4 fibers, 8 fibers at the same time and use them, not only is that going to give you a lot of resiliency, but you're also then pushing down that cost on rolling out more cables, more fibers in the actual future. And the third benefit is bandwidth. Because in the link aggregation group we have 2 or 4 or 8, typically it's always a power of 2. I'm just going to stop drawing there. Because we've got these link aggregation groups which are part of the same bundle, what we can effectively do is actually load, share or hash frames, packets over all these links at the same time. So as such, we can increase the bandwidth. So no longer are we limited to only one connection going from one source to one destination, but now we can have multiple connections all recognized as the same connection, all being used simultaneously. But really the question is what is link aggregation group? A good textbook answer of this would be it's a combination of Ethernet interfaces to form a virtual connection and increase bandwidth. A lot of writing there, I know, but I just wanted to write that all down. A link aggregation group, really the answer is in the acronym itself, link aggregation group. We are grouping together different Ethernet interfaces into a single common virtual group, and as such those devices, those VX switches, those VMX routers, or those Cisco or whatever vendor it may be, because this is an open standard at the end of the day, and I'll come on to that in just a second, but we will all recognize that from a vendor perspective as that same physical, or I should say virtual link, and as such we will load, share packets and frames, i.e. traffic, over all those links that are part of that virtual aggregated group, so we can effectively increase the bandwidth whilst also providing network resiliency as well. Now, as I just said, link aggregation group, or LAG for short, it is an open standard and it is actually defined in the 802.3 AD. Now, it's not to be confused with 802.1 AD. This is for really the service providers where they're doing queue in queue. So don't get 802.3 AD and 802.1 AD confused and mixed up. If you're talking about link aggregation group, we are talking about 802.3 AD. But interestingly, what I've learned through my studies is actually this has been re-standardized, re-ratified, updated. So it's actually now falls into a new standard called 802.3AX. So you can look through it online if you wanted to read that IETF specification. I'm sure it's not very big, complete lie there. I'm sure it will send you to sleep if you read it. But the 802.3 AD is actually now updated, re-ratified, re-modernized to be falling under the 802.3 AX framework. But nonetheless, it is an open standard. But one thing you do have to be aware of is some vendors do like to create their own versions of these open standards. And of course, every vendor does it. But if we look at Cisco, what they also do is alongside their link aggregation group protocol, they also do PAGP, or port aggregation group protocol, if I remember correctly. So there's different variations, there's different formats of really the same thing, with each vendor doing their same thing, unless they don't do a proprietary protocol. But really, when we talk about LAG, link aggregation group, it is an open standard which all vendors typically support, and it is supported under, yes, the 802.3 AX framework, but traditionally, as we all know it to be, the 802.3 AD framework. So I've just wrote on the benefits of link aggregation group just to keep it up there, but I've said a few things which I just want to go over very quickly. So as I said, there is a power of 2 when it comes to link aggregation group. So if we just look at these two switches here, or these two VMX routers, I keep calling them switches for some reason, they're actually routers, so apologies for that. But it's a power of 2. So you're either going to have 2, 4, or maximum of 8 Ethernet interfaces within that same link aggregation group, i.e. that aggregation of interfaces. So you can't have 3, just for example, because that's not a power of 2. And so I'm just going to draw out 4 connections here just for an example, because what I want to go through is the hashing algorithm. Now there's many different ways to do hashing. You know, there's MD5, there's hashing you could do at layer 3, there's hashing you could do at layer 2, and that's really what I want to talk about in terms of the link aggregation group hashing, is how we actually hashing, how we deciding, or how the device is deciding on what link to actually send those frames down. Because if we look at it from R19's perspective, it can send those frames over to R22 on this link here, or it could do it on this link here, or it's got a third option here, or it's even got a fourth option all the way up here. So how is it actually going to decide on how to actually forward that information on all those frames? What interface is it actually going to choose within that bundle? And that's where the hashing comes into it. Now, even though link aggregation group is a layer 2 function, it's a layer 2 mechanism, the hashing algorithm actually looks at a lot more than just the layer 2 header. So what the hashing algorithm looks at is the layer 2 source and destination MAC address, but it will also look at the layer 3 source and destination IP address. So now we're talking about layer 3. It will also look at the layer 4 source and destination port address. And it doesn't just stop there, it could also, and there's a big word there, it could also look at MPLS labels, as well as the different types of packets. So it could look at IPv4 type of packets, it could look at IPv6 type of packets. So there's a lot that actually goes into a hash algorithm. It's not to say that the Juniper devices will use every single one of those values, of those variables, to actually derive the hash. If it's only got a layer 2 frame, then it's obviously not going to have any of the layer 3, layer 4 or higher or other information to derive that hash algorithm. But basically what we're doing here is we're saying, right, if this frame or packet is coming from the same source, going to the same destination, is of the same type, going to and from the same source and destination ports, etc., then I'm going to send it over this link here. And then it's going to keep a record of that and identify in the future, in the nearby future, if the same flow of information, if the same flow of packets has arrived with the same source, same destination at layer 2, layer 3, layer 4, etc., I'm going to send it over the same link. However, if it has a different destination at layer 2, layer 3, layer 4, or it's a different type of packet, then maybe I'm going to send it over a different interface within that aggregated group of Ethernet interfaces, i.e. the lag itself, the bundle itself. And as such, through that hashing algorithm, regardless of the amount of links that we actually have, yes, they're all actually operational at the same time in an active scenario, but the bandwidth should be proportional. So we should be getting some information, some packets, some frames being sent over one link, the other's been sent over another link, the other's been sent over another link, and so on and so forth. If one of these links fails, then the link aggregation group protocol, or LAGP, is going to say, it's going to identify, oh, hang on, this link here has gone down. Let's now rerun the hash algorithm and let's send all that information that was going to go over that group over another interface itself. So this is the hashing algorithm that's used. Typically, you don't really need to know this, but you just need to know in the background that there is a hashing algorithm in place, and that is how, in the Junos world, these switches, these routers decide what interface to actually send those frames, those packets over. So that's what link aggregation group is. But just in summary, what it is basically a bundling. It's an aggregation of different Ethernet interfaces into the same virtual group. It's a bundle basically. Now what I'm going to cover now is something that's closely linked to link aggregation group, but it's not actually the same thing in that it's controlling the communication between the two different switches, or in this case the two different routers, i.e. between two peers. But it's not necessarily to say that you need this, and what this is Link Aggregation Control Protocol, or LACP. You do not need LACP for Link Aggregation Group to actually work, but it's highly recommended that actually you do use Link Aggregation Control Protocol, or LACP, however you want to pronounce it, because it adds a lot of extra benefits on top to that link aggregation group, and that's what I'm going to go through right now. And there we go, I've just quickly wrote it on there. So LACP, Link Aggregation Control Protocol. Now, as per the standard 802.3 AD, or as we now know, really reformatted, modernized under 802.3 AX, there are two different ways of actually configuring that interface. Whatever the interface actually may be, it doesn't matter. So you can either configure it as active or passive. What active means is that switch, that interface on that switch, on that router, is actively sending out LACP packets to try and get and trying to establish and really monitor that link aggregation group connection is still there. It's basically a keep alive. It's a heartbeat saying, I'm actively sending out LACP packets. Are you there? Let's bring this link up. Let's bring this link up. Let's bring this link up. Passive is when that interface on that switch, on that router, is not sending out any LACP packets, but it will respond to LACP packets. And it's very similar to OSPF and BGP and ISIS passive command, where we can configure that interface to be passively advertised into that protocol, but not actually sent any of that same protocol advertisements out of that interface. It's the same kind of concept in that we are just waiting for an active peer to send LACP packets, and when we receive the LACP packets, we're going to establish that link aggregation group and we're going to respond to those packets. But there's the big catch, is that you cannot have two peers on that same link on those interfaces configured as passive. One has to be active, one has to be passive. To be honest, in the ideal world, I would say typically always have both ends set to active. I don't really know a situation when you'd have one set as active and the other set as passive. But it's a good troubleshooting tip for you there. If that link aggregation control protocol is not coming up, it's not being established, you're not seeing LACP packets being exchanged, just check, are the two interfaces actually both configured to be passive? Because if they are, they're not sending out any LACP packets. They will only do so when they receive LACP packets. And another part that you need to be familiar with and understand with LACP is this periodic interval. What this means is how often are we actually going to send out LACP packets to ensure that that interface as part of that bundle is still up and still up. It's almost like a BFD, or bidirectional forwarding detection in that aspect. It's, as I said, it's a keep alive to ensure that that interface is still up and still able to pass traffic. So periodic basically means how often are we going to send out those LACP packets. Now in Juniper Junos and with all vendors under the 802.3 AD standard -AX, there are two different formats or two different ways. We could do this fast, or we could do it slow. Now fast basically means that an LACP packet is going to be sent out every 1 second. So every 1 second we're sending out an LACP packet. Is this link still there? Is it still there? Is it still up? Are we still able to generate traffic? Are we still able to pass traffic? Every 1 second. So for me, that's pros and cons, because that's quite maybe a lot of control overhead that's going over that one link. It might be unnecessary and really not needed. Whereas with slow, it's sent out every 30 seconds. So 30 seconds is quite a stretch. If that link has gone down, then we're not going to really see that for 29 seconds, maybe 30 seconds, when the next LACP packet is actually sent. But then it's less overhead that's actually been sent over that link itself. So there's pros and cons to both sides. But what you absolutely do need to know is that Junos, we automatically by default support the fast periodic interval. So by default on Juniper Junos devices, LACP packets are sent out every 1 second. However, with other vendors like Cisco, depending on version and model, I would presume, but I believe that Cisco on iOS every 30 seconds they send out an LACP packet. So will a LACP connection still work? Will there still be distribution and collection of LACP control information between two peers if one's configured in fast and one's configured in slow? And essentially, yes, it will still work. However, it's good practice to have both peers both set to the same periodic interval, either fast or slow. So it's just something to be aware of when you have Juniper Junos devices to a non-Juniper Junos device like Cisco's. Always check what's the periodic interval, because there may be a few gotchas and a few errors along the way. So just to keep things clean and simple, best to have them to have the same periodic interval. Now there's another point that I actually want to cover when I'm actually referring to Cisco, because as I said a few minutes ago, is that they actually support their own proprietary protocol for LACP, and that's PAGP. So I just wrote the two different modes of PAGP onto the display. So there's desirable and non-desirable. For me, they're very similar to the LACP active and passive, but it's a proprietary protocol from Cisco. So obviously it has to be a bit different. Now the point that I want to make here is that you cannot have LACP and PAGP working together. It would be like saying, oh, I want OSPF and EIGRP from Cisco working together. It's just not compatible. That's the word I was trying to think of there. So you can't have, for example, one peer here on one interface configured as LACP active and the other peer on the same interface at the other end configured to be desirable or non-desirable. It's not going to work. So again, when you have different vendors connected together, if you are using link aggregation group and have link aggregation control protocol or LACP running over the top of it, ensure that they're using the same protocol, either LACP ideally, because it's an open standard at the end of the day. And so I've just removed PAGP from the display because obviously the concentration is not on Cisco IOS and PAGP. I'm not going to go there for obvious reasons. However, I just wanted to find a few more attributes and functionalities you can get with the link aggregation control protocol. So one thing that we can do in Juniper Junos devices is the force up command. Now this is actually a really handy command, because when we've got two switches or routers, I keep calling these devices switches, but they're not, they're routers. I don't know why I keep doing that. But basically, if one of these peers has reduced functionality, so I'm just going to put an R there for reduced functionality of LAGP, whereas this device here supports all the functionalities of LAGP, what we can actually do on this interface here, if it's over this connection here, we could say, well, I want to force this connection up. Not the connection, but I want to force that interface up for LAGP, for LACP, and obviously for the link aggregation group. Because this has reduced functionality, it might not support all the functionalities of LACP, but here we're actually saying, well, I don't actually care about that. I want LACP to be up on this interface, and I want to start collecting and distributing LACP information. So it's actually a very useful command, that, but there's also other commands that we can do, such as a backup or standby link. Here you can actually see, obviously, we've got two connections between R17 and R19. We've got this GigE001 interface and this GigE002 interface. Now, important note is that the interfaces don't have to be numerical order. That could be GigE001 to then the next interface GigE003 or GigE0010, whatever. It doesn't have to be numerical order, but obviously you need at least two interfaces to have a bundle within a link aggregation group. But back on topic, a backup allows us to have one working, or shall I say active. So I'm just going to put active here, and this link here to be standby. So standby, backup, non-active, however you want to phrase it, it's the same thing. But using the backup command, we can actually say, well, this interface here is actually a backup. So if this link here goes down, LACP using through these periodic commands, these periodic intervals, is going to detect either 1 second or 30 seconds. Hang on, this active link has gone down. I'm now going to switch over to that backup link. And as such, because we've got this backup, you do need a way to define, well, which peer is going to be that master and which one's going to be that non-master. And that is where we also define a system priority, system ID, and on the interface we can also define the port priority as well. So obviously it's a bit more in depth that, but it's a protocol at the end of the day, so it's going to have quite a lot of functionality to it. But what the system priority basically is a combination of a 2 hex value followed by the MAC address, and typically the lower the value, the more preferred that system actually is. So say this had a value of 01, just for example, and this had a value of 02, and then whatever that MAC address is of that, and I'm just going to write MAC there. Don't know what happened to my notepad, and MAC, whatever the lower value is, that peer on that interface is going to be more preferred. So the MAC is obviously the MAC address, the layer 2 address of that interface. So in this case, the interface here would be more preferred over to this interface here, because this has a higher value of 02 and whatever the MAC address is. So this would then become the master. This would then become the switch, which is dictating via the port priority which ports will actually be active, which ones will be standby. So as you can see, there's a lot that we can do with the Link Aggregation Control Protocol. As I said, it's a protocol at the end of the day, so just like any protocol, there's a lot of features and a lot of functionalities you can get within that. Having said that, just remember, you don't need LACP for Link Aggregation Group or LAG to actually work, but it's highly recommended that you do so because it gives you more benefits on top of that Link Aggregation Group. So that's enough for me talking, so let's actually just now jump onto Secure CRT and actually start showing you how quick and easy it really is to configure Link Aggregation Group and then LACP on Juniper Junos devices. And so here's the scenario for this lab. What I've got is actually a BGP connectivity or adjacency built over from this network here on the right hand side. So this is Enterprise B, and to this service provider here. If you don't know about BGP, if you want to know a bit more about BGP, check out the content that I've created on BGP and all its variations. Here's one of the links just up here, but that's not the focus for here. The reason why I'm showing that is because what I want to do, the scenario which I want to do, is first I'm going to absolutely get rid of that BGP adjacency from Enterprise B to that service provider. I'm just going to tear it down, get rid of the adjacency over these connections. And then what I'm going to do, of course, is build the bundle, the aggregated Ethernet, the LAG, the link aggregation group between R17 and R19. And once that's done, I'm then going to configure the LACP, the Link Aggregation Control Protocol, to run over these different interfaces. Then I'm going to re-establish the BGP connectivity, and then we're going to test the failover. We're going to test, well, if one of these links goes down, so say 01, GigE001 is just disabled, do we still have that BGP adjacency between the service provider and Enterprise B over the GigE002 interface? So that's what we're going to go through right now, step by step. First off, let's just quickly disable the BGP. So I'm on R17, and let's just go into the command line interface and quickly into configure mode, and I'll do edit protocols BGP, and let's do show, and you can actually see here are the two BGP groups. Now the one that we need to focus on here just very quickly is actually the external group here. So what I'm going to do is I'm actually just going to delete these two neighbors, which is pointing to these two IP addresses on on R19. So let's do delete. Let's do delete group external 65100 neighbor 170.10.20.17, and do the same command again, .21, and I'm just going to commit to that configuration, and I need to do the same on router R19 to make this really clean. Let's do edit protocols BGP, do a quick show, and let's delete the group external AS3 pointing to the neighbor 170.10.20.18.22. Let's do a commit. And back on R17 now, if I just do quickly a run show BGP summary, then you can actually see the only connection I've got on R17 now is in the opposite direction. It's pointing over to another router which is not R19. Basically, BGP is now torn down, and I can now build that link aggregation group. So how do we do that on Juniper Junos devices? The absolutely first thing that you need to be aware of is, unlike Cisco IOS, where you just define a port to be part of link aggregation group, in Junos there's an extra step that you do have to do, and it will catch you out if you don't do this. We have to define in the chassis that it's okay to use aggregated Ethernet. If you don't do this and you configure the interfaces to be part of a aggregated Ethernet group and configure LACP and you commit it and everything seems to be working fine, if you haven't done this step, you will not see LACP coming up. You will not see that aggregated Ethernet bundle within the show interfaces terse command. It simply will not be there. And that is because you have not enabled the chassis to commit and to have a aggregated Ethernet group. So it has to be configured within the chassis. So don't forget this step. It's very important. To do it, very straightforward. You simply do set chassis aggregated Ethernet devices Ethernet device count, and then we simply define how many bundles of aggregated Ethernet do you actually want on this device. That's basically it. Now for this scenario, I'm only going to use one bundle, but if you wanted two, you'd configure 2, 3, you'd configure 3, and so on and so forth. But this is such an important command, I can't emphasize that enough. Do not forget it. It will catch you out if you do forget it. So I'm just going to do set chassis aggregated devices Ethernet device count 1, and that is the first step done. The next step is we actually then have to change and modify, really get rid of all the information that's configured on the GigE 001 and GigE 002 interfaces. So let's do edit interfaces and let's do show GigE 001. So now I can see that GigE 001 has got unit 0, family, INET, address, so on and so forth, and it will be the same, but obviously a different address for GigE 002. Now we cannot have that on Juniper Junos devices. We define the IP addressing within the aggregated Ethernet interface, which we haven't configured yet. That's the third step. The second step right now is we need to define these interfaces to be part of that aggregated Ethernet group, which is that third step again. So in this step, what we need to do is actually I'm just going to delete GigE 001.0, which is unit 0, and 2.0. And now I'm going to do set GigE 001. And if I hit question mark, you can see here, and this will change from MX to EX switch to QFX switch. Typically the EX switches and QFX switches have the same option. But on the MX routers, we've got Giga Ether options. On the on the EX switches and QFX switches, you will see Ether options. It's obviously a slight different naming in terms of the command, but just to make you aware, on MX routers, currently at the time of me doing this video, it's Gig Ether options, but on EX switches and QFX switches, it will be Ether options. So what we have to define is Giga Ether options, and I've hit question mark just to show you through it. We then have the 802.3 AD. This is what we need to concentrate on. So no, this is the traditional legacy standard, which has been again modernized under 802.3 AX, but traditionally we know it as 802.3 AD. So let's do 802.3.AD, and I've hit the question mark again. Now you can see we can figure a little bit more information, and note we've also got LACP. We could define this link to be that backup as well. We could define it to be the primary, hence coming back to which link will be primary, which link will be the backup or standby, etc. So what I'm going to do here is I'm going to go under LACP, hit question mark, and now you can actually see that's where we define the port priority itself. But all I need to do here is, if I actually just go back, all I need to do is actually define what aggregated Ethernet group or bundle do I want this to be a part of. So I'm just going to do AE0, and now if I just do show GigE 001, you can see that's really the configuration. I know I was talking a lot there, but it's a straightforward configuration. You define the interface without the unit or sub interface, Giga Ether options, or again Ether options on switches, and 802.3 AD, and then that bundle itself. So just quickly, if I do set GigE 002, Gig Ether options, 802.3 AD, AE0, and now do show GigE 002, you can now see that these are both configured for 802.3 AD, and they're both pointing towards that same aggregated Ethernet bundle. Now that is the third step, is that we need to then define the aggregated Ethernet bundle. So let's do set AE0, which isn't created yet. And if I hit question mark, note right at the top, we've got aggregated ether options. So this is what we need to define. So set aggregated ether options, hit question mark, and we can then start going through LACP. So this we do have to do. So LACP, and now I could define, do I want this port to be active, which is what I was defining before? Do I want it to be passive? Do I want to force the connection up? Do I want to have an administrative key? I'm not too sure what that is. I'd have to look at the Juniper Junos documentation. The periodic interval as well. System ID, system priority. So that's part of if you want to have that backup link. Again, that's done at the interface level itself for the GigE001 or GigE002 in this case. But here I'm just going to do periodic, and I'm going to say fast, and I want this to be active as well. So now if I do show AE0, you can now see we've got aggregated ether options, LACP. This is going to be actively sending out LACP packets every 1 second. I didn't really need to do this part, it's just to show you, because again, by default on Juniper Junos, it's automatically set to fast. But what I also will do is do set AE0 LACP, or aggregated Ethernet options, can't forget that, LACP, and I want to force that interface to be, or LACP on that interface to be up itself. Now if I actually just do a commit check on here, and you can see that's now succeeded, and I'm just going to commit to that configuration and then go over to R19 and do exactly the same thing, because obviously we've got 2 routers or 2 switches, whatever they may be, and we've got links in between them, so you need to configure both ends. So let's go on to R19. Let's just go to the top, edit interfaces, and I'm just going to delete GigE001.0, 2.0, and now I'm going to set GigE001 gig ether options 802.3 AD, and then point the way to the bundle itself, and then go and do the same for GigE002. And now I'm going to do set AE0, so it's the same Ethernet bundle or aggregated Ethernet bundle that R17 has now been configured to. And I'm going to do set AE0 aggregated Ethernet or ether options, LACP. I want to do periodic fast, force up, and I want to be sending out actively the LACP packets. Now if I just do show AE0, we can see that we've configured AE0 to be using LACP, actively sending out LACP packets every 1 second, and I'm going to force that LACP on that aggregated Ethernet bundle to be up. And now if I just do show, just quickly, GigE001, GigE002, what you can basically see is that these 2 interfaces here are pointing towards that 802.3 AD bundle, and we've configured that bundle up here to have these specific attributes. So now if I just go top and commit this, and obviously that's now committed successfully, and I'm just going to quit out of here actually, and let's just do a quick show command to see, do we have LACP actually working? So let's do show, actually before that, let's do show interfaces terse, and let's just see, do we have a aggregated Ethernet up? What is GigE001 and GigE002 looking like? So both of these are up, GigE001 and GigE002. Note they do not have any iNet address, and there's no Ethernet switching on here, because if I go nearly to the bottom, and you know what, I forgot that command which I told you not to forget. It's just caught me out, and this is a good example of it. If you forget aggregated Ethernet device count in the chassis under show interface terse here, you do not see AE0 anywhere. It's caught me out. We're all human, we make mistakes. So let's go back into configure mode. Let's do set chassis, aggregated devices, Ethernet, device count 1. Now I'm going to do commit and quit. And now that should work, or it will work. And now we should see AE0 within the show interfaces terse command. And so there we go with the new edition of the chassis with that device count of aggregated Ethernet 1. We've now got AE0 shown here with the unit AE0.0 up with this iNet address. So I just added quickly an iNet address onto the aggregated Ethernet bundle, and just to show you that, if I just do show configuration interface AE0, what you could basically see is I just added in a unit here. So I just went into configure mode, done set unit 0 family iNet, and I just added in the bundle to have this IP address here, 170.10.20.17, and I've done the same on R18. So if I just go into show AE0 here, you can actually see the IP address here of the AE0. So it's obviously very important. But if on R17, if I just go to the top, so let's just do it from here. If I do run show LACP interfaces, what we can now see is that everything looks great. We basically have these different roles. So one is going to be an actor, i.e. the master. One's going to be a partner. I'm going to have to look into what FUP actually stands for. I think that means force up actually, but I need to confirm that. Have any of these actually expired? No. Are they using default configuration? I think that is no. Are they distributing LACP control information? Yes. Are they collecting? Yes. Are they in sync? Yes. Are they aggregated? Yes. What timeout are they using? So they're all using fast as well. And are they active or passive? So they are all set under active. So that's the link aggregation control protocol state. And then we've got the protocol itself. And this is the important part, is they are currently sending every 1 second periodically. They are sending and collecting or distributing that LACP information. So that's great. So that is the third step of building LAG and LACP. Again, do not forget, like I did, we're all human, we make mistakes, that command to enable aggregated Ethernet within the chassis itself. And just to reaffirm that, that is within the chassis. You have to do set aggregated devices Ethernet device count and how many bundles you actually want. Do not forget it. But now that fourth step is, as I said, I wanted to rebuild that BGP connectivity. I know it's not the nature of it, but can we actually have BGP connectivity over an aggregated Ethernet or LAG with LACP running alongside it? Well, let's give it a test. So let's go into Edit Protocols, BGP Group, External AS65200. So that's just the autonomous system for Enterprise B. And let's do show, and I want to set the neighbor to be 170.10.20.17. So that is the IP address up here. I'm just using the lowest one. I could have used .21 and .22 on these interfaces here, but I just chose .18 and .17. Don't ask me why, it's really not relevant. But here we go. So I'm going to set the neighbor there, and if I just do a quick show, looks good. So I've now got the neighbor command here. Again, if you want to know more about BGP, just here's another link if you want to check out the content. But let me just commit that configuration and quit. And back on R19, because we need to do the same thing here, it's going to configure mode, and it's do set protocols BGP group external AS3 pointed to the neighbor 170.10.20.18. So that is the GIGI 001 IP address over here on route to R17. And now I'm going to commit and quit this configuration. So those commands, those configurations have now been committed into the running configuration. So now let's just quickly check the BGP summary. So show BGP summary, and you can now see, here's the important one here. So on route to R17, we wanted to build the adjacency from the 170.10.20.18 over the aggregated Ethernet bundle AE0 to 170.10.20.17. Now you can see 170.10.20.17 is established. Basically means it's up. So we now have got routing over an aggregated Ethernet bundle. That could be BGP, it could be OSPF, it could be ISIS. It really doesn't matter about the routing protocol. This is working. But what happens now if I was to disable one of these Ethernet interfaces within this bundle itself? Let's give it a test. So I'm just going to give a bit of a pause here. So what I'm going to do just in the background is I'm just going to disable, or I'm going to suspend, I should say, the GIGI 002 link. So you can now see that's suspended here. We've got the two nice little red dots. Let me bring back up my secure CRT. Let's now do the show LACP interfaces. And you can see something's changed here. So we can see the GIGI 002 interface is now gone to passive because this is passively down on the partner end. And you can see it's obviously a change, so it's detached on the GIGI 002 interface. So obviously that's to be expected because I've just disabled it. So LACP is working there. So GIGI 001 is still up. It's still distributing and collecting information because it's part of that bundle. But GIGI 002 is basically down. But do we still have BGP? Do we still have routing over this bundle? So let's do again, show BGP summary. And you can actually see we've still got 170.10.20.17 established. even though we have 2 interfaces within this bundle, it could be 4, it could be 8, etc. They are all using, on one end, obviously, they're using one IP address, and when one of those links goes down, when one of those interfaces goes down, LACP, as long as there's one left, will continue to run, and we still have routing over that link aggregation group bundle. And so there we go, everybody. That is the end of this video. It's the end of this content. I hope you found that useful. I hope you found that informative. A lot of people think that link aggregation group is straightforward, and to be honest, it really is. It's just a bundling of Ethernet interfaces into a virtual group. It's a bundle. But when you add on top of that link aggregation control protocol, things get a little bit more interesting. But we saw the benefits that you can get with LACP on top of link aggregation group. So LAG will provide reduction in costs in terms of deploying fiber and cables from the same source to the same destination again in the future. It increases bandwidth, and it also increases redundancy for that network. So all of those are obviously very important for any type of network. When it comes to LACP, there are huge benefits to this. So the ability to use an open standard 802.3ad with different periodic intervals, 1 second or 30 seconds, to have a backup as well to designate which peer is going to be an active or actor, which one's going to be the partner, port priorities, and so much more. So I hope you found that useful. If you liked it, please give me a like, please subscribe. Any questions or comments, please let me know down in the comments box. I love hearing from you guys. Thanks for watching, and goodbye.